Today's video is all about subsets, okay? So I have a set B here. It have A, B, C, D, E, yeah? And what is a subset of that? Think about it as what is, it now will contain all of them elements here, but it can contain some of them. It's kind of like that, right? So a subset could be like A have A, B, and C. And the main thing you have to realize is once the elements in A, you can find them in B, then you know that that is going to be a subset, okay? Meaning that I can find all of A within B. That makes sense, right? So then how do I write it with the notation now? A, this is the symbol now, write it down, is a subset of B. The words A, set A is a, right, I can't even spell, is a subset. No, man, the spelling problem is an issue. Subset of B, all right? That makes sense? Yeah, so then you want to make a note of that. If I can find all the elements in one set in another one, then that means it's a subset of that bigger one, all right? Now, another thing that CXC likes to ask you, how many subsets can you find from set B? Okay. Now, for the interest of this video, coming, I want to make it too long. I'm going to break down B into 3 elements, not all 5. Okay. Now, if I want to list out the subsets for B, I want to make sure you understand this. We're going to go one by one. So the first subset, the null set, which is the empty one, is always a subset of every set. Write it down. Number 2 now, the set itself is always a subset of the set, okay? Because all elements can be found in that other set, right? So 2 we're gone so far. Let's go 3. Now, remember, make sure we say this, okay? This set, we're going to talk about what it means to be equal. Is the same thing as me having A, C, and B. It's the same thing as me having B, C, and A. What you notice, all of the elements are the same, right? And so they're all what we call equal in set theory. So when a set is equal to another set is when they have the same exact elements as another one. That's what it means to be equal. All right. So I'll drop a little nugget there. All right. Now, do I have to write out all of those versions of it? No, because they're all equal. So I'm not for keep on, I'm not for double count it or triple count it, you know. Once I have A, B, C as I said, that is it. I'm not for reorder it or anything like that. All right. Now let me go now and say, well, I have 3 elements in this one. So let me try and create subsets that have 2 elements now. How we can have 2 elements, people? We can have A with B. We can have what else? You tell me. B with C. Yeah, man. The 5th one now. What's that now? A with C. Yeah, man. And then we're going to go to what's next? We can have A by himself. We can have B by himself. And then we can have C by himself. So what have we just did? These are all of the subsets for this set B. Okay? How much did we end up getting? 8 of them. Okay? Now, let's make sure we understand. How do we get the subsets? First one we always know is a null. The next one is always a set itself. And then we go through all the different variations that are possible in terms of, you notice I went to 2 elements and I went through all the versions of 2 elements, right? Then I went through 1 element and all the versions of 1 element, yeah? And then we keep on and then we add up how many subsets. Now, when CXC asks you this though, they don't want you waste time like that. They don't want you waste time like that. So they have a formula here. So the number of subsets from any set is equal to 2 raised to the n power. Now, people, let's talk about it. N, write it down. That's the number of elements in the set. So when I look at set B, how much elements in there? 3. So then the number of subsets would equal to 2 raised to the 3rd power. Now, I know say bunch of one gonna tell me, say, sir, 6? 6 of the answer, because you're going to do 2 times 3. Let's make sure we address that right now. Okay? When you see me put a number and then the next number at the top, let's make sure we understand. This is called the base. This is called the exponent. Yeah? It's not 2 times 3. So let's make sure we understand it. So when you see it like this exponent is telling you how many times the base going to repeat. So I'm going to say 3. So I'm going to write 2 3 times. Then fill it in with multiplying, man. And then 2 times 2 is what? 4. 4 times 2 is what? 8. That is you working out an exponent. Write it down. Okay? So the number of elements, number of subsets, sorry, is going to be 8. And that match when we did it the manual way and went through all of the different types of subsets for the set. Okay? So I hope that's making sense. So now let's go through another example. First, let's do a little exponent drill. All right? So I'm going to give this. I'm going to give you 3 raised to the 3rd power. What's that? 2 raised to the 4th power. What's that? Yeah, my nostrils are going with some things, man. I don't know what's going on. Allergies or something. 5 squared. So when you see it raised to the 2nd power at the top, right? That's a secret name for squared. When you see it raised to the 3rd power at the top, that's cube. When you raise to 4th, it's not a special name. Adjust to the 4th power, right? So go on, get to work, right? And then we're going to go to 6 to the 3rd, or 6 cubed. Sounds good? Now, what did I say to you before? The exponent, the number at the top, tells you how many times the bottom number base is going to repeat. So it's 5 and a 5. Multiply them. 5 squared is then 25. Ready, go. Let's set go. This tells me 4 times more repeat the number at the bottom, which is 2. 2 times 2 times 2 times 2. Now see 4 of them, right? 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. So that is you working out or evaluating exponents. Got it? This one now, 3 times 1 to the base. So I'm going to say 6, 6, and 6. Right? So 6, 6 is 36. This times this is 36. 36 times 6, what's that? Don't push your calculator, please. Go work it out. All right? 216, right? For those of you, 36 times 6, 6 times 6, 36. Put down 6 down here, carry my 3. 3 goes over here. 6 times 3 now, 18. Then you add whatever you carried. So that gives me 200, that gives me 21. 18 plus 3 is 21, right? And that gives me the 216. No calculator, man. You're supposed to be able to do that in your mind, yeah? This one tell me, repeat the base 3 times. So the base is 3, so 3, 3, and 3. All of them are going to multiply now, yeah? So then 3 times 3 is what? 9. And then 9 times 3 is what? Because them 2 here give me this. Don't? So 9 times 3 now, 27. Are you done? So welcome to exponents. A little side note. We want to make sure that everybody have a little skill there. All right? Now, let's get back to subsets. Let's go again now. So the key formula we learn, the number of subsets in any set is equal to 2 raised to the n power. So if I say, all right, I have a set of these. 1, 2, 3, 4, and 5. I'm going to say how much subsets can be formed with this. Yes, people, I'm not bash it, you know. You can go down the list if you want. But what you're going to start to realize is you're going to be wasting a lot of time in the exam. So the empty set, that's a subset. We're done. Number 2, the set itself, that's another subset. Write it down. Yeah? But then we would have to go through all of the different versions of how 4 elements can go in there. It can be 1, 2, 3, 4. Then I have to go again and I'll say 1, 2, 3, 5. Then I have to go again and say, well, what else we can do again? I don't even know. 1, 3, 4, 5 is going to be a lot of work. So that's what I just wanted to make sure you explain what subsets are, right? But then we want to make sure we use a formula to speed up. Because remember, these are subsets because all of their elements can be found in this set here. Okay? So now to use a formula now, the number of subsets is going to equal to what? Let's go. Number of subsets will equal to 2 raised to the n. Now, n stands for the number of elements. So go count up the elements, the man. So the number of elements, let's bring this back from video number 1. This is set A, by the way. So the number of elements in set A So that's what, you know how I said it in words, but I wrote just two things in letters. That's what the two things in letters stand for in words. The number of elements that can be found in set A would be equal to, add them up, 1, 2, 3, 4, 5 elements, right? So then now when we go here, I say 2 raised to the number of elements, which is 5. Then you just learn exponents from me, don't? The exponent tell you how much time the base going to repeat. So then it's going to be 2, 2, 2, 2, and 2. Finity would multiply. And then go get my answer, please. Right? 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2. If you don't know it, go calculate it the long way, please. 32. So there's 32 different subsets that this set has. All right? So hope that makes sense. We'll go into Venn diagrams and visualizations of sets in the next video. All right? Later, don't forget to like, share, and subscribe. And then also in the comment section, let me know what you're struggling with in the curriculum. Maybe we can just do a little shout out video on that. All right? Later.